In lesson 6.3, we're going to talk about some arcs and some angles. So in this first picture, what I want to show you is the difference between central and inscribed. So an inscribed angle is half of the measure of the central angle. That is assuming that they intercept the same arc. So take a look, first of all, at the arc that's being intercepted. That's arc AD. Notice how both of these angles are intercepting that arc. I have one angle, the central angle, ACD, and this angle is 70 degrees. So we're talking about the central angle ACD. But if I look at the inscribed angle, not the central one, but the inscribed angle ABD, which is intercepting maybe is the better word, the very same arc, this angle will be half of that value, or in other words, 35 degrees. So an inscribed angle is going to be half of the measure of the central angle, considering they intercept the same arc. In the second slide here, what we want to show is that if we have two angles that are inscribed intersecting the same arc, they are the same size. So if I were to tell you that I'm looking at arc AD, for example, and you knew that this arc was 70 degrees, then what I would tell you is that, first of all, I know that angle ABD in red is going to be 35 degrees because it is half of the intercepted arc. And also, angle ACD in purple is going to be 35 degrees as well because it's intercepting the same arc of 70 degrees. And we learned recently that the inscribed angles are half of the central, and the central angles were the same as the intercepted arc. So in this case, we know that the inscribed angles will be half of the intercepted arc. Since they both intercept the same arc, they're both going to be the same size, and they're both going to be half of 70. In our third slide, what we learn is that any inscribed angle that intercepts the diameter, or in other words, is inscribed in a semicircle, is a right angle. So we know that if we look at the arc that is a semicircle, this green arc right here, and we were to understand that that semicircle is 180 degrees because it's halfway around the circle, that means that I also know that angle ABE, which is an inscribed angle intercepting that 180 degree arc, would have to be 90 because it's half. That's this one right here. That also means that angle ACE in blue, intercepting the 180 degree arc, since it's inscribed, would have to be half of the 180, or in other words, 90. And finally, just a third example for fun, angle ADE in purple is also intercepting the semicircle A to E in green. That's 180 degrees because it's halfway around the circle. So that inscribed angle in purple would have to be half of that intercepted arc, or in other words, 90 degrees. In any case, any inscribed angle that intercepts the diameter, which in this case I'm going to denote in light blue, will be 90 degrees. Any inscribed angle that intercepts the diameter will be a 90 degree, or in other words, a right angle. In our next slide here, what I want to show you is that when you inscribe a quadrilateral, meaning a four-sided figure, inside of a circle, the opposite angles will be supplementary. So I draw this inscribed quadrilateral here in light blue. And what I see after I inscribe it, meaning that all of its vertices are on the circle, is that angles that are opposite add up to 180, or in other words, are supplementary. So look at angle A, 120 degrees. Look at angle C, 60 degrees. Those total up together, when you add them, to 180 degrees. That's what supplementary means. Also, if I look at the other two angles, angle D and angle B, and I look at their total measurement, I see that these are opposite to each other and their total is 180 degrees, or in other words, they are supplementary as well. So opposite angles of an inscribed quadrilateral are supplementary, or in other words, they total 180 degrees. Finally, in our last slide here, what I want you to know is that parallel lines intercept congruent arcs of a circle. So the first thing that I'm going to tell you is that the lines M and L are parallel to each other. That's what this part is saying. If I know that these two lines are parallel, what that tells me is that I know that arc AB and arc CD are congruent to each other. So parallel lines chop off two congruent arcs.